Hi there, it's Professor McDonald, and in this video I'll be explaining the difference between a student t-distribution and the standard normal distribution. And I'm going to begin by reading from the textbook from section 9.3, Distribution Needed for Hypothesis Testing. Earlier in the course, we discussed sampling distributions. Particular distributions are associated with hypothesis testing. Perform tests of a population mean using a normal distribution or a student's t-distribution. Remember, use a student's t-distribution when the population standard deviation is unknown and the distribution of the sample mean is approximately normal. We perform tests of a population proportion using a normal distribution, usually n is large. All right, so there's more information here, but let's focus on the part just in this first paragraph, which says that when testing means we have a choice between the normal distribution and the student's t-distribution, and that we make the choice based on whether or not we know the standard deviation of the true population. So that would mean the symbol that represents the true population standard deviation is the symbol sigma right there. Right, so if you don't know sigma, or if in other words sigma is unknown, you will use a student's t-distribution. We also say if n is large, you can use the normal distribution even when you don't know the standard deviation of the population. I'm going to demonstrate the t-distribution compared with the normal distribution so that you can understand why we allow use of the normal distribution even when we don't know the standard deviation, as long as we have a large sample. I'm going to use GeoGebra to show you the different distributions. The first one I have up here already is the standard normal distribution. I'm going to zoom out a bit. So there you can see the mean is 0, the standard deviation is 1, that's what makes it standard. The bell curve is what makes it normal. And we can look at the student's t-distribution with 10 degrees of freedom. That would mean that the sample size was 11, since the degrees of freedom for this type of test would be n minus 1. You can tell that the red curve, which represents the t-distribution, is very, very similar to the blue curve representing the standard normal distribution. On the red distribution, along this horizontal axis, we would have t-scores, and along the blue, the horizontal distribution would be represented by z-scores. So there seems to be very little difference between them, but remember, we're dealing with probabilities to help us know when we're making a good decision regarding our hypothesis. So little bits of difference can make a huge amount of difference in whether or not we're making a type 1 error. If you look at the tails, zoom in on the tails, you can see where those differences are. With the t-distribution, we have much more probability of making a type 1 error than we do with the blue line. Now, if we have a larger sample, let's say a sample of size 101, that would make our degrees of freedom 100, and the t-distribution is much closer to the blue line than the red line is. And also notice that if we go up a little higher with 300 degrees of freedom, you can almost barely tell the difference between the blue and the purple. The purple representing the t-distribution and the blue still representing the standard normal. So that's why we say use the t-distribution if sigma is unknown. Use the z-distribution, the standard normal distribution, if sigma is known or if you have a very large sample. Because we're not always sure when our sample is large enough, and in many cases the samples won't be, anywhere close to 300, we would err on the side of caution and just go ahead and use the student's t-distribution whenever we don't know the true population standard deviation. As a summary of what we've learned in this section, we've learned how to choose the correct sampling distribution for a hypothesis test, claims about proportions, claims about a mean with known population standard deviation, in other words, when we're given sigma, claims about means with unknown population standard deviation, when we're given S, but not sigma. In short, the claims about proportions, you will always use z-scores, the standard normal distribution. If it's a claim about a mean with known sigma, then we'll use the standard normal distribution. The only time we have to use the t-distribution is if we're doing a claim about a mean with unknown sigma. All right, now, just so that you know, even though we may not be covering it in this course, there are also hypothesis tests about standard deviations, and we would use the chi-square distribution in that case.